Okay, the second half of the mechanics of how encryption works involves keys. We talked about algorithms a bit earlier. The key is the second half. The key works with the algorithm, which is a mathematical formula, to encrypt and decrypt information. Now, as we said before, the algorithm is usually publicly known. Okay, that's not a big secret, and several methods use the same algorithm sometimes, and people can use the same algorithm all over the world. Many people use the RSA algorithm, many people use DES, many people use AES. That's not the secret part. The secret part is the key that goes with that, because that makes the algorithm transform the plain text into ciphertext in a certain way, and that certain way is encrypted. Now, keys, we can think of keys in terms of numbers or passwords or passphrases, but actually they can be long complex numbers themselves, and they're usually randomly generated by the program that uses the encryption. So often you might be asked to put in a key such as a number or password, and that password might be used to generate another key that's used in the encryption process, or that key, that password, can be the key itself. So in any case, keys should be kept secret, and they're normally like a password or a number or passphrase. Now, we know that the algorithm is public and the key is kept private. The key is the variable that goes with the algorithm. Keys can change, algorithm will probably stay the same. Here's an example of how encryption with the keys and the algorithm works. You have some plain text, a document, a phrase, text, whatever. You add that with the key and you feed that to the algorithm. The algorithm takes that key and that plain text and combines it together to encrypt it, to alter that message, and the result is ciphertext. And of course, when we decrypt something, that's exactly the reverse. For example, when we look at the two diagrams on the screen, in the first one we have plain text, and this plain text is fed through a block cipher encryption. That's our algorithm, okay? It might be DES, for example, or triple DES. That's our block cipher encryption. The key is thrown in there to transform the text, okay, the plain text. The result of that transformation is ciphertext. Now, the decryption process, as I said, works the exact opposite. We take the ciphertext, we feed that into the block cipher, the encryption algorithm. Okay, in order to transform that back to the plain text that originally went in it, you have to add the same key. So that key is thrown in there and transforms that ciphertext along with the algorithm back into plain text. That's very simplistically the way the encryption and decryption work, and how it involves keys and algorithms. You have to have both to make the process work both ways. Encrypting something with the key and an algorithm results in ciphertext. In order to decrypt that, you have to use the same algorithm, of course, and the same key. Using a different key will not decrypt and will not produce the plain text that was originally used. So that's how keys and algorithms work. And again, we didn't go too much into the mathematics of it, and we're not going to. You just need a rudimentary understanding of the mechanics of how this encryption thing works.